Today we are replacing one of the motors in the Gravedigger. We run these motors. We buy them on Amazon. We use these for the Gravedigger. The only car that we run them in is the Gravedigger. They're a 20,000 RPM at 24 volt 895 size. Let me grab a stock Gravedigger motor and show you what those look like. I grabbed some motors for reference. Here is the stock Gravedigger motor. I believe this is an 895 size can. It is a little bit smaller. Nah, it's something smaller. It's not quite an 895. It's pretty close. So this is an 895. This is what I run. This is a 20,000 RPM at 24 volt. Stock is 14,000 RPM at 24 volts. So there's a little bit higher speed, and I don't have torque numbers on it, but it definitely does seem to have more torque and speed over the stock motor. They do last pretty good. I run them 24 volts. I run 2 lithium iron phosphate batteries in series for the 24 volts. The really working voltage is about 28 volts, a little bit higher than the stock lead acid voltage. Not enough to really make a difference though. The lithium iron phosphate can output higher current and hold that voltage though over lead acid batteries, unless you're talking a really large lead acid. I just have reference here on Andy Mark 775. These are really good motors that we run in a lot of applications. We did try these in Gravedigger, and Gravedigger was just too heavy. This motor is too high of an RPM. They're like 20,000 RPMs at 12 volts, and we're running 24, so we're talking 24,000 RPMs versus 20, and it doesn't have the torque this motor has. This has significantly more torque. And another reference is just, this is a stock size 550 stock. Standard Power Wheels comes with 550 stock. And so that's just kind of a size comparison. This is a Traxxas Titan 21 turn. It's worn out. Brushes were worn out on it. Those can handle 18 volts with like a single passenger pretty well. But if you're trying to drive 2 kids around, they seem to burn out pretty fast. 2 passengers with Andy Mark 775s, that's pretty good, up to 10 miles per hour on a lighter weight vehicle. These in the Gravedigger is about 8 miles per hour with 24 volt batteries. Okay, let's get started on the replacement. Let's move all these out of the way. What you're gonna need to replace the motor is new motor. I use heat shrink because I solder the motor wires directly to the lugs. I don't use spade connectors, female spade connectors. They can fall off, they get warmer. It's a worse connection. I have a soldering iron. I use a Weller soldering iron, a big one for this application. I run 10 gauge wire on everything to all the motors, even though typically the motors don't really support 10 gauge. 10 gauge is bigger than what they, the hole in here, you can't fit the 10 gauge wire through. So I strip it down a little bit. So you're gonna need wire strippers, going to need wire cutters. If you don't have self-stripping, automatic stripping wire strippers like this, you can use just standard wire strippers. Need a heat gun. Recommend, these are like 20 bucks on Amazon, and you just put a whatever power tool battery you have in it. You're gonna need 1/2 inch or 13 millimeter sockets and a normal drill. Step 1, pull the nuts off the vehicle. Now, our Gravedigger has the my kids wheels. So there's different spacers used to get those spaced correctly. And then they have special adapters to go between their standard wheel and the Gravedigger gearbox. I only have to take off this side. This is the only bad motor. So this one doesn't spin, it's seized up. This one spins freely. There's 2 reasons that these motors can seize up. Most common is the fans kind of melt, which I'm suspecting that's what happened here since my kids were running around in the mud with it and filling the motor with mud. Now there's a bunch of screws in here. Now, let me show you a little bit more what we have going on with this Gravedigger. I'm going to hold the phone. So we have those softer springs. I'd say those aren't worth it. They're really soft. Yeah. So what we have is we have a prototype Peanut Workshop speed controller in here. This one's good up to, we're targeting 88 volts. That's the max voltage out of a 72 volt lithium iron phosphate battery. 72 volt lithium ion battery max voltage is 84 volts. So any 72 volt battery, up to any 72 volt battery should be good. That's what we're targeting. So that's what we're running in here. I need to unscrew the motor wires for that wheel so I can pull those wires out. And these are the batteries we run. We run 2 of these in series. They're 16 amp hour, 12 volt lithium iron phosphate batteries. They're cheap. I think we pay $45 a piece for them. All right, let me put you. So the advantage here, you can't run all the current through these switches. They're going to fail immediately. All right, not immediately. They're going to fail really quick with this kind of power. So you want to get rid of, you got to bypass these. Some people use relays. That's why we designed the speed controller, is to bypass the foot pedal, use a variable pedal, and then, so now this is just a logic switch on off to tell it forward or reverse. We don't have a high-low for this unit. It's just forward and reverse, but okay. Oh, also this has a 12 volt output. We run the 12 volt output to power all the factory lights. You hit the button, hit whatever button you want. All the sounds, all the lights, everything still works as it should. The Gravedigger is supposed to be 24, but we run it on 12 and it works just fine. Okay, need a screwdriver. All right, gearbox is out. Got to pull these 2 screws out, pull that motor off. So what I'm going to do, I'm going to cut these wire leads off right here. And there should be enough slack where I can reuse these wires. Again, this is 12 gauge. Try to use copper core 12 gauge for any big power applications like this. This is the old motor. I do have a spacer in there to try and get a little more airflow. I think they're from Andy Mark. I think that's where they came from. I don't want to pop that off. Should be the same motor. There's no label on this one, but I'm pretty sure it's the same one. As far as I can tell, they're identical construction. So let's see if we can see this. You can definitely tell that those brushes were overheating. Probably can't tell on camera, but they're all discolored. And the fan looks fine. So most likely with this one is some of the windings got too hot and melted, and that's why it was seized up. All right, so you got to pull the pinion gear off this motor, put it on the new motor, and then we'll be ready to go. Pulling the pinion gear off, just find the right size Allen wrench and unscrew it. So you know the stock motor is not a 5mm shaft. It's one size bigger. I forget the exact value. It's in inches. So it's just a little bit over 5mm. So you can't use the stock pinion gear on any of these 5mm shaft motors. You're going to need a new pinion gear. No, this is down with it. See, I'm right off. So when the pinion gears are difficult to get off, I just put them in the vise and hit them with a hammer and punch. I don't think I have any spares 13 to 32 pitch 5mm. Oh, I'm gonna have to try to get this off. The problem is to use the pinion gear puller, there has to be space underneath it, and you have to. What I decided to do, since this is a junk motor anyways, is I put it in the vise, press the motor shaft out. Now I got space, so let me grab the pinion puller. Here is a pinion gear puller. Once you have it adjusted right, You just slide it in, and then there's a little pin in there that's going to push against the shaft of the motor and hopefully pry this pinion gear right off the shaft. There we go. Got the pinion gear off, ready to go on the new motor. This motor is junk. It's going to go in my junk pile. I have a box of all of the motors the kids have burnt up. Let's solder these wires on first. Plug in the big soldering iron. Put some shrink tubing. I think I'm out of the optimal size I like. Strip the wires back just a little bit. And then what I do is I twist them nice and tight and then bend them at a 90-degree angle. And then I go to put them in the motor hole, see if they fit. When they don't, I go down a size in the stripper. So I'll go down to 12 gauge, strip off a whole bunch of strands, try again. There we go, that went in. But I want to put some shrink tubing on there first. This is shrink tubing with an adhesive in it. So sticks really good. I want a little less here. This makes a really strong connection with the soldered to the lugs of the motor, and then I usually do black to the non-red. Typically every motor has some kind of red marking. It doesn't matter because you're gonna change the polarity to get the right wheel direction anyways once it's in the vehicle. So there we go. I got that bent over along the tab. No strands are sticking out. You don't want any strands to be able to touch the casing of the motor. Now I'll just kind of hold that in place. If the motor's moving around, you can always put it in some wire strippers or something to hold it still. Solder. The type of solder you use is really important if you want to be happy. Use Weller leaded solder. Flux core Weller brand flux core leaded solder. Don't buy lead free if you want it to melt easily. If you don't want to use lead, then buy lead free, and make sure you buy flux core. Give it some heat. Now when you're doing this, you're going to want to make sure that the solder flows both on the wire and the tab. You don't want just the solder on the wire or solder just on the tab. You're going to get it covered, but you don't need a lot. Oh, there we go. So there we go. That's pretty good solder joint. You got to make sure it flows through the backside too, and then just put your heat shrink on top of it. And you're going to want to kind of do that kind of fast to make sure it doesn't shrink down before you get it in place. There you go. That is pretty secure connection. That's not going to come off. Now let's do it to the other one. There we go. Now, so motor break-in, that's a hot topic. If you're running these kind of industrial style brushed motors at their rated voltage, I don't break them in. That's me. Break them in if you want. If you're running like an Andy Mark or a Vex Pro or a Traxxas, I would recommend breaking those in. But this one, these are huge brushes. It's really operating in its rated range. I don't break them in. So again, if you want, you're not buying them from me, so it doesn't matter what I say. Now, this is a slightly larger diameter, the collar on here, so you do have to press that on pretty hard. I used the vise, pushed it on. it's good now. Just make sure everything fits before I put that pinion gear on. Yeah, we're good. All right, pinion gear on the Gravedigger. The primary gear is really close right there inside this hole, and you have to make sure that that set screw is in far enough, otherwise it does rub and it makes a horrendous sound. So kind of some trial and error there and getting that position just right. This is going on tight, just like the other one came off tight. Gonna press it down with the vise, which is good. So this shaft doesn't have a groove for the set screw to actually rest in. So here, grinding just a little bit. Push it on a tiny bit. I think we're good. Okay, I'm gonna put the set screw in. I put a little bit of Loctite on it in that hole. I do, if the pinion gear doesn't have to be pressed on the shaft, I'll put some Loctite on that shaft to help hold that pinion gear in place so it doesn't slip. I've never had an issue with these slipping, so I don't do much. All right, let's put it in. Sounds good. All right, let's get it put in the car. I mounted the speed controller back behind the seat, so I got a few holes drilled in here to pass wires through. So this speed controller that we're in the middle of development is a single H bridge or dual half bridges. Designed it for 80 amps continuous through the full H bridge, or 80 amps continuous through each half bridge. So if you don't need reverse, you could run 80 amps out of both channels simultaneously, 160 amps total. Continuously, I've tested up to 100 amps. Thermals look good even at 100 amps through each channel. So let's power it on, make sure we get the right motor direction. All right, we're in forward. That wheel's spinning forward. Forward. Reverse. Yep, we're good. All right. Now just mount the wheels. All good now. There we go. Son's gonna be happy. It's been a couple weeks since we were out camping and burnt up the motors. So, I hope you enjoyed watching me replace a burnt up motor. Thanks. Yeah.